Hi all, so this is going to help you out with this assignment, just a little overview of what this assignment is all about and how to get going on it. So the part A here, the first part, you'll probably find not too difficult. This part is what you've been doing in your lesson 1. So if you've been finding the drawing field lines not too much of a problem, that's basically what you're doing here. And if you've watched the video that I made on this lesson 1.1, so that's what this is from, lesson 1.1, I actually did a couple of these ones for you. So make sure you check that out. So you're drawing the field lines for each of these different objects. And yeah, we know that all objects have a gravitational field. But I want you to identify the most significant field for each of these diagrams, right? So if we've got a bar magnet, we're not going to be drawing gravitational field lines. We're going to draw magnetic field lines, all right? And I'm telling you that because this one's already given to you. I just noticed the answer's already in there. Okay, so you just need to draw the lines. So each of these images is a drawing, so double click on the image and then add your lines for showing the field direction. Make sure you show the direction of those lines, okay? They're just not lines, they're arrows. All right, and then the next page, part B of this lesson, of this assignment, is all about the effect of mass and distance on G. Remember, G is your gravitational field strength. All right. So your goal in question 1 is to explain qualitatively and quantitatively what happens when the gravitational field strength, what happens to the gravitational field strength G when you increase the mass of an object by 2 then 4 or decrease the mass by half or a quarter. By what factor does the gravitational field strength change by? Okay, so when you're talking qualitative, so that's the first section. Qualitative is like a description, right? What's happening to the gravitational field strength? Is it getting bigger, smaller, bigger by a lot, smaller by a lot? So you can words like that. You don't need specific numbers. I just want you to give me an overall view of what's going on when you make these changes. So you're going to use this interactive here from Classroom Physics. It's on the gravitational fields, and you're going to use it in your explanation of what's happening here. So you can do a screen capture video like what I'm doing right now. You could use that interactive and take still images and capture them and put them in a slideshow to explain what's happening. Whatever you end up doing, those are your two options. So you need to it has to be a very visual explanation. You're going to paste your link to if it's a slideshow or a video in this box. Now, if it is a slideshow, you should have, if you're logged in, you should have this screencast, and that's what I'm using, Screencastify, when I'm doing my recordings. It should be, if you're in your Black Gold account, you should have that free to be able to use that. But anyway, so you're going to pop over to the interactive here. And for example, like say I'm going to get started on this and I want to see I'm going to show you what happens when the moon's mass doubles. Okay, so right now, let's say the moon is at 20. I'm going to put it to 40. Watch the force. What was the force at? Force was around 46.6. And look at the arrow. Okay, the arrow here is the vector representing the force. So what happens when we go from a mass of 20 to a mass of 40? So a mass, I'm doubling it, so a factor of 2. That arrow may have also doubled. If we measured it using this awesome ruler that moves, we could see if it doubled. We can also look at this force. Did it double? How did it change? So this is what you would be doing in that qualitative description. You can see the force increased by a lot. It looks like it roughly doubled. We don't need to have specifics. Let's say, so basically this is what you're using so to represent and show the changes. And so the other part where in the second part of the assignment is you're going to look at the mass of the planet, no, not the planet. The planet is not going to change. The distance. So say you start here and your two masses are 3 squares apart, or you could use a ruler to get a bit more specific if you want. And I'm going to double my distance. So from 3 squares, I'm going to 6 squares apart. What happened to that force? Well, the force got a lot smaller. Did it get a third smaller? Did it get half smaller? How much smaller? So maybe it's easier to see if we started at 4 apart, and then move to 8. Like how is that force changing? So that's the kind of description you want to do in your little interactive video that you're going to make for me. Or if you want, you can do the screen capture where you're taking a picture of the screen, popping it in there and showing the difference and explaining qualitatively. Okay, so that's the qualitative part where you're doing an explanation of what's going to happen for goal 1. So you're increasing the mass by 2 and then 4, and then decreasing the mass by half and 1/4. And it doesn't matter what mass you start with. Use whatever mass you want to do this explanation. And then quantitative, this next section is all about numbers. So I want actual data. So you're going to answer these same questions, but you're going to collect that data in this table here. Right, so same goal. What happens when the mass changes? So pick your original starting settings for your interactive, whatever they might be, your mass of your moon, your mass of your planet, and what is that gravitational field strength. Then for your first trial, you're going to increase the planet mass by a factor of 2. A factor of 2 just means double the mass, right? So if it was 10, it goes to 20. And so write the new masses here and the new gravitational field strength. And then here it's saying factor the field strength change by. You can't really see this, but it's the new field strength divided by the original field strength. And that'll give you a number. Okay. And that's your factor that the field strength changed by. All right, so basically you're going to just do that for all these different trials. You're going to increase the mass by 4, decrease by half, and then increase the planet by 1/4. And then overall, you've got 2 overall summaries here just to say what overall happened quantitatively when you increase the mass and then when you decrease the mass. And then goal number 2, I'm thinking you're going to guess what's going to happen. Now you're focusing on the distance between the 2 objects are causing the gravitational field. So you're going to do it again. You're going to look at what happens when you increase the distance between the center of the objects by 2 and then by 4. And then you're going to decrease the distance between them by half and by 1/4. And then your goal is to figure out what factor does the gravitational field strength change by. So you're going to do this again qualitatively, like show me what happens using a video or some still captures. And then you're going to actually collect the data to prove what happens and come up with an actual explanation using numbers on what actually happens. Okay, and then the last part, I'm basically just giving you some field strength calculations. So you have these from your textbook too. So the first one is to find the gravitational field strength at the surface of each of the moons described in the problem here. And then you need to find the force of gravity. So don't get that confused. Remember, there's that second formula. So you've got the field strength formula, and then you use that field strength to find the force of gravity on the astronaut that's on the surface. And then same thing, there's a question, but this time it's the electric field. Okay, so you're finding the electric field strength. And then you are then also finding the magnitude of the electric force. Okay, again, similar, you're going to use that electrical field strength to find the electrical force on a speck in each of these locations. All right, if you have any problems or questions, make sure you get a hold of me.